I guess the buzz phrase lately has been the Colorado
Yes.
low. The science behind it, it's important in meteorology, and Jacob, you're going to tell us all about it.
I am, yeah. So growing up in Connecticut, I really liked nor'easters. As a snow lover, these storms came up the East Coast. What happened was you have an area of low pressure coming across the Appalachian Mountains in the eastern part of the country. It weakens over those mountains and then redevelops along the Atlantic coast and impacts Connecticut a lot of times with a lot of snow, which I was excited about. A similar thing happens with Colorado lows coming into the west coast. These areas of low pressure coming in to the Pacific coast weaken as they go over the Rocky Mountains. The upper level energy maintains itself as it goes over that high terrain, and the low level surface low redevelops in Colorado. That's why we call it a Colorado low. As it moves up towards the north and east into the northern plains, it draws Gulf of Mexico moisture in from the south. All of this moisture fuels severe thunderstorms in parts of the Midwest with these Colorado lows. Like Iowa has a potential for seeing severe weather tomorrow. On the backside of these systems, snow and wind is often a very common theme with Colorado lows in North Dakota, as we're seeing tomorrow, because of the colder air from Canada being drawn in on the western side of the very strong, intensifying area of low pressure as it tracks up into the Great Lakes region. So let's go back 36 hours. We can see this big spin in the atmosphere coming into California, moving across the Rocky Mountains, bringing a lot of snow to Utah, Idaho, even parts of western Montana. But that area of low pressure weakened as it was going over the Rocky Mountains. Now we're seeing it re-intensify in northeastern Colorado. That upper level energy that I was talking about can really be identified using water vapor satellite imagery. You can see that spin in the atmosphere way into the west coast of California. This was during the day on Tuesday. That's when that big ball of energy was coming in and allowing for the storm system to get over the Rocky Mountains. Now we're seeing it currently on radar and satellite intensify in northeastern Colorado. These lines of equal pressure, isobars, show us where that area of low pressure is now developing. Our Colorado low is in the process of intensifying on the east side of the Rocky Mountains and will track up to the north and east. We also need other ingredients in place to deliver a major winter storm. We need an area of high pressure to our north to deliver cold air into our region for that snow to fall. We have that in place. Over parts of Alberta and Saskatchewan, the strong area of high pressure is supplying the cold air into North Dakota that we need for a lot of snow to fall. Also, well off to the east, there's an area of high pressure along the eastern seaboard. This very strong area of high pressure is allowing for counterclockwise flow and for that Gulf of Mexico moisture to be drawn up to intensify our Colorado low, give it enough moisture to deliver a lot of snow to our area in the coming days. Well up in the atmosphere where planes fly, 30,000 feet or so, we can look at the jet stream, a very fast ribbon of winds that really delivers where these storm systems go. It's a highway of sorts for areas of storminess to move across the country. Now the jet stream is really dipped down across the west coast. This is what we call a trough. As you see that big dip in the jet stream across the western United States, that can allow for storm systems to intensify to the east of that trough over the central part of the country. All the ingredients are coming together to really intensify the system over our area. We can also identify jet streaks, or areas that are faster moving winds in the jet stream, 30,000, 35,000 feet above our heads. So these pink colors right up here, those are jet streaks, faster moving winds. In certain parts of those jet streaks, you get a lot of upward motion. Rising air fuels these storms to allow them to intensify further. The right entrance region of a jet streak, so if you imagine this to be our very fast ribbon of winds aloft, the right entrance region promotes rising air, and that allows for our area of low pressure. More rising air can intensify that area of low pressure, our Colorado low, even further. So again, everything really coming together to form our system. Areas of low pressure, our Colorado low, counterclockwise flow around that area of low pressure, drawing in colder air on the backside, our cold conveyor belt, and that's allowing for our precipitation to fall in the form of snow as we go over the next 24 to 36 hours. I'm going to end on a stat here because this is a little bit early in the season for seeing a snowstorm of this magnitude. The biggest snowstorms before Veterans Day, November 11th, There's a few in our history, one somewhat recent, 2019, when we had almost 17 inches of snow towards the beginning of October. But the one that we'll be chasing with this storm in Bismarck will be from 1986. So we'll see if we can get to that number, kind of on the upper end of our range for Bismarck snow totals. But a lot of interesting details there about Colorado lows and how they form.
Good stuff. Hey, why not? We might as well break a record, right?
I'm just
This
happy.
close.
You're right. If you're going to be close to a record, break the record. But if we didn't have the Rocky Mountains, this whole environment and the dynamic process of the atmosphere wouldn't even be the same. We
Yeah.
wouldn't have lows like this. We wouldn't have these surface lows form. So we're thankful for the elevation differences to give us this exciting North Dakota weather, right?
It should be a great one.
Should
As
be.
only meteorologists can
Right.
say.
Right.
Exciting.
Stay safe, though, everyone.
Yes. Thank you, Jacob.